Okay guys, let's have a little look at the intro then. I'll run you through all the things we need for this section. Polar coordinates is the first thing that's mentioned in the first few questions. And basically what you do is you draw a horizontal line, which is the OX axis. This is the origin. Generally I write the y-axis as well, to be honest with you, although that's the Cartesian measure. But polar is basically you're told an orientation of an angle, theta, and then you're told a distance radius out from O of r. So this point here, for example, is out a distance r here and at an angle theta, and that's the point P, which is here. And that's how you do it. So for example, if you had out 1 at 60 degrees, this angle here would be 60, and it would be out 1, so 160 would be there. 60 degrees. So, and the bigger the angle, of course, the more you go around. You start from 0 and you can go around to 360 or 2 pi radians, and you go in the anti-clockwise positive direction. That's it. So for example then, imagine if you had -1 at 90 degrees orientation then. That's your r is -1, theta is 90. So you'd go around to the vertical line. There's your orientation 90 degrees from here. There's around 90 degrees, and you go forwards from O a distance of -1. So that would mean you'd come back down here because you're going forwards -1. So you're going back 1, aren't you? And there's the point P2, say. So that's what there is. We'll do some questions on polar coordinates, but that in a nutshell is polar coordinates then. So let's have a look at Cartesian, which we should all be fairly familiar with anyway. So next is Cartesian. And let's have a look at those. So Cartesian then, basically we're all familiar with this, I would imagine. You draw your customary XY axes. When I'm doing polar, I generally write the y-axis in as well, just because for the sake of preference really, but you shouldn't, I suppose, if you were being pedantic about it. But here's our Cartesian axis. So for example, if I wanted to write down the point 1, 1, this tells me how far to go along in the x direction, which is the forwards, positive forwards direction is this way. And this is the y direction coordinate, of course, and that's the forwards direction for y. So you start from the origin. This tells you to go forward 1 and up 1. Forward 1, up 1. And there's our point P at 1, 1. And then if you have, say, 2, 1, 2 in the x, you'd go along, instead of going along 1 unit, you go up 2 units and you go up 1. So that would be the point 2, 1. And then, of course, if you were doing 2, -1, you'd go along 2, as before, but you'd go up -1, and in a sense that's going down 1, isn't it? So that's the coordinate 2, -1 there. And then if you had, say, -2, -1, that tells you the x coordinate go back 2. You go forwards -2, which in essence is saying that you go back 2. And this is going up -1, so that means you go, up -1 is the same as going down 1, isn't it? So there's -2, -1. So I've got several questions on plotting polar coordinates just to get us comfortable with the subject and how the XY grid is arranged for Cartesian coordinates. So that's that one. Let's have a go at the next one then. Now the next thing I want to mention, now we're doing Cartesian coordinates, which is what we're going to do the rest of the stuff on. Let's have a look at length of line, shall we? So let's draw our axes again. Our OXY Cartesian axes. There's x, there's the origin, there's y, and we're worried about wonder about the length of the line. Then suppose we want to, so I'll just write out the formula for you. Here's P1, which is x1, y1, and suppose we have P2, which is here, and that would be x2, y2. Okay, so we can draw a triangle, can't we, between these 2 points conveniently, like so. So what is the length of this line L? So the length of line L, which we've denoted by L here, is, well, we use Pythag, don't we? We've got a right angle triangle. What's this distance here? Well, it's the difference between what we went from and to in the x direction. So we were at x1 and we went up to x2. So the difference is the bigger take the smaller. So it'd be x2 minus x1. And that's L squared, because we're doing Pythag. So that would be that squared is equal to the sum of the other two sides squared. The height difference is this height take away that height. So as a formula then, here's the formula. There's the height difference, and square that. If you can see that there. So if we're doing if we just want L, then we have to square root both sides. So square root of L squared is L, and then you need to square root the other side, don't you? So there's our formula then. Here, for the length of side is self-evident when you draw a picture, and simply use Pythag. So that's the length of the line done then. So let's go on to the next one. And that will be, what have we got then? That will be, well, let me just get rid of this first, what I can of this. Okay, I'll just tidy it up, if I can. Well, that'll have to do. Okay, right, so the next thing I want to talk about, midpoint is the next easiest thing to get. So let's draw our axes again. And do the midpoint. I hope you can read that. So if we draw our Cartesian axes, because that's what we're doing in the examples, here's O, here's X and Y. So you've got a point P, which is X1, Y1 again. So we're doing the same again. And P2, X2, Y2. And we want the middle point done with the halfway between these 2 points. So we'll get the formula then. Again, we just draw a triangle. What's halfway between? We'll do the midpoint and we'll label it M. So here M is equal to what coordinates? Well, you started at X1, you went up to X2 horizontally. So halfway between the two is if you add them and divide by 2, you'll get the midpoint. So add them and divide by 2. Can you see that? So for example, if that were 10 and X2 were 20, then when you add them, 10 and 20 is 30. 30 divided by 2 is 15. 15 is halfway between 10 and 20. So it's always a good idea when you've found your midpoint just to make a visual check with the numbers to see that you haven't made a silly mistake. The same goes for Y2 and Y. This is Y1 here. I've managed to write Y2 for some reason. So the midpoint here then for the Y's, halfway between Y2 and Y1. You just add them again over 2. There we go. So there's our formula for the midpoint. It's self-evident, it's intuitively clear. When you draw a picture, you can remind yourself exactly what the formula is to use when you're looking at concrete examples. So again, if Y1 was, say, 5 and Y2 were 15, say, then when you add 5 and 15 up, you get 20. 20 divided by 2 is 10. 10 is halfway between 5 and 15, isn't it? So I hope you can see that that is actually, in practice, that's the correct answer. So that will give us the midpoint. So the only other awkward thing now left to talk about is the median, which is slightly less trivial. So let's have a look at the median then, shall we? Okay, the median. So what have we got? Median. Oh, let's not do that. Let's just draw a triangle and think about it in terms of the Cartesian coordinates then. So here's our triangle, which we can label ABC. Okay, if you take any one side, like the AB here, and find the midpoint M, and you divide it into 2, so we can find the midpoint, and then the median. If we drop a line from C to that midpoint M here, straight line, then the median is defined to be the point that's a third of the way along. So it divides this part into proportions of 1/3 to 2/3. So the same process applies. We can find the midpoint, which is half, and it's just a sliding scale. So it appears a third of the way up between this coordinate and that coordinate. So if this M were, say, M1 and M2 as coordinates, and suppose this was C1 and C2 as coordinates then, well, to find the third of the way up, what you would do is you'd have the M1, you'd start from here, say, and you'd add a third of the difference. Yeah, which would be a third of the difference, that length in terms of the x coordinate, would be C1 minus M1. That would be your x coordinate, wouldn't it? Because that would be the M1. You start here, you need to add on a third of the distance along in terms of the x coordinate. So the difference in the x coordinate is C1 take M1, and a third of that. The y coordinate which I'll snick just down here. Put the c coordinates up there. Now we'll put in the y coordinate. So again, it's m2 is the y value here, and you go a third of the way along. So it'd be c2 is the y value minus m2, and a third of that difference. c2 minus m2. So that's how we get it, because it's a third of the way along. Incidentally, had you wanted the midpoint between these 2 points, that would be a half. Can you see that? And you'd end up with the same formula we had from the midpoint when you expand the brackets. So there's your median then. Everything we need is now done. I know I've dragged it out a bit here, but that's all the bits and bobs we need. So all the best in this section, and hope you get on okay with it. Cheers!